Right now, floating nearly 1 million miles from Earth, the James Webb Space Telescope is delivering images that don't just refine our understanding of the universe, they rip the foundation out from under it. Galaxies too massive to exist, so early in cosmic history, stars being born in places that should burn them to ash, planets with atmospheres that seem engineered rather than natural, and black holes that grew faster than physics should ever allow. Each new dataset challenges the laws we thought were unshakable, leaving scientists scrambling to rewrite the story of how the cosmos came to be. For decades, we believed the universe followed predictable rules. Galaxies building slowly, stars forming in fragile nurseries, planets evolving under familiar chemistry. But Webb's vision has turned those assumptions upside down, revealing a cosmos filled with anomalies, contradictions and mysteries that feel closer to science fiction than science. What it's showing us is that the universe is far stranger, far older, and possibly far more alive than we ever dared to imagine. And the deeper we look, the more it feels like reality itself is bending under Webb's gaze. When Webb peered deep into the cosmic dawn, just 400 million years after the Big Bang, it should have found only faint smudges of infant galaxies, tiny clusters of stars barely holding together. Instead, it revealed monsters, colossal galactic titans, already spinning with billions of stars, some larger than the Milky Way itself. The shock was immediate. According to every cosmological model, galaxies are supposed to grow slowly, piece by piece, through countless mergers and gradual star formation over billions of years. But these giants looked fully mature at an age when the universe was barely 3% of its current lifetime. They had spiral structures, dense star clusters, supermassive black holes at their cores, and chemical signatures rich with heavy elements like oxygen and carbon. Those elements are supposed to require generations of stellar birth and death to accumulate, yet here they were at a time when only a handful of stars should have existed. It was as if an oak tree had grown overnight in a field of freshly planted seeds. The discovery forced astronomers to confront unthinkable possibilities. Maybe dark matter works differently than we believed. Maybe the laws of gravity behaved in ways we no longer see. Or perhaps primordial black holes born in the Big Bang seeded these galaxies into instant existence. And the strangest part wasn't just their size, it was how many there were. Webb found dozens of these impossibilities scattered across the early universe, suggesting this was not some rare cosmic accident, but a common phenomenon. If entire galaxies could emerge in the blink of cosmic time, then the very framework of how the universe grows may be broken. But if galaxies could grow impossibly fast, what about the black holes at their heart? Black holes have always been thought of as patient feeders, taking billions of years to swell into giants. But Webb has uncovered something that should not exist. Supermassive black holes sitting at the centers of those ancient galaxies, fully grown when the universe was still in its infancy. One of them weighs in at tens of millions of solar masses, yet it appears just a few 100 million years after the Big Bang. According to Einstein's equations, no black hole could possibly grow that quickly, even at the maximum feeding rate called the Eddington limit. It should take billions of years to reach such a size. And yet, there they are, ancient monsters that seem to have skipped the line, devouring matter at speeds that defy physics. Some scientists suggest they didn't grow at all but were born massive. Primordial black holes formed directly from the Big Bang itself. Others propose exotic processes, like gravitational collapse happening faster than relativity allows, or even mechanisms that no longer operate in our universe today. What makes them even stranger is how they seem to behave. Webb's instruments have caught signs that these black holes might not act as isolated objects, but as a coordinated network. When one changes in brightness, another across vast distances shifts in response, as though they are somehow connected. They even release gravitational waves that appear before the light from the same events arrives. hinting that time itself is distorted near them in ways we can't explain. If galaxies were forming too fast, these black holes were growing even faster, rewriting the rules of gravity and suggesting that the engines at the heart of the cosmos are far stranger than we ever imagined. But the anomalies didn't stop at the largest structures in the universe. They also reached into the very stars themselves. Stars are supposed to follow a delicate script. Clouds of gas cool over millions of years, collapse under gravity, and finally ignite in fusion once the pressure is high enough. But Webb has caught stars being born where no stars should exist, in violent regions that should tear them apart before they can even form. In the wreckage of supernovae, where temperatures reach millions of degrees and radiation blasts everything in sight, Webb's infrared eyes revealed glowing protostars taking shape, as if flowers were blooming inside a furnace. Even stranger, these stars don't take millions of years to ignite. They leap from raw gas to fully burning suns in just a few thousand years, skipping entire stages of stellar evolution. Some are so young they should contain only hydrogen and helium, yet their light shows heavy elements like carbon and oxygen, which normally require generations of older stars to exist. It is as if these newborns were infused with the chemical legacy of stars that had never lived long enough to die. Stranger still, many of them shine far brighter than their size should allow, burning with the energy of stars dozens of times more massive. That shouldn't be possible under known fusion laws, unless they are tapping into processes that bypass the rules in our textbooks. Some researchers suggest dark matter may be fueling them. Others propose exotic quantum effects that let them tunnel past normal gravitational constraints. Whatever the cause, Webb has found that these impossible stars are not rare. They appear in clusters, forming together, even showing signs of synchronization across vast distances, as if connected by some hidden thread. If even stars can be born where physics says they shouldn't, then what about the planets that orbit them? Planets are supposed to be predictable. Rocky worlds near their stars, gas giants farther out, atmospheres shaped by chemistry we understand. Yet Webb has found worlds that shatter those expectations, with skies that look more like science fiction than science. One planet orbiting a star just 50 light-years away shows oxygen levels higher than Earth's, nitrogen in impossible concentrations, and water vapor held aloft in atmospheric layers that should collapse under their own weight. Even more unsettling, Webb detected traces of industrial-like pollutants, compounds that on Earth only appear from advanced technology. And this is not an isolated case. Dozens of exoplanets show atmospheric cocktails that should not exist, with heavy elements in bizarre ratios and gases that ought to break down instantly in starlight. One, known as HD 4037J, has an atmosphere of metallic hydrogen in gaseous crystalline forms, creating shimmering layers that behave like solid structures while still remaining gas. Even stranger are the synchronized changes. Planets separated by light years shift their atmospheric chemistry at the same time, as if responding to a shared signal. Some atmospheres even contain molecular structures that look disturbingly like they're self-replicating, growing more complex over time, as though alive. These patterns force astronomers to consider unthinkable possibilities. Either our models of planetary chemistry are fatally wrong, or something is actively modifying these worlds. And if planets are being shaped by unknown forces, what does that say about the galaxies that host them? The deeper Webb looked into those galaxies, the stranger the chemistry became. Heavy elements like gold, platinum, and uranium, materials that should take billions of years of stellar deaths to accumulate, were found in pristine abundance when the universe was still a toddler. In one ancient galaxy, Webb detected technetium, an element so unstable it should vanish in a matter of millions of years, yet it lingered in structures billions of years old. Even more bizarre were the isotopic ratios. Instead of the random scatter expected from chaotic stellar explosions, the elements appeared in precise mathematical patterns, as if someone had followed a recipe. Some spectra even hinted at super-heavy elements beyond the known periodic table, stable over cosmic timescales, when our models say they should disintegrate instantly. These findings suggest the early universe was running nuclear processes that don't exist anymore, or worse, that these galaxies were seeded with manufactured matter. In some cases, the distribution of elements across a galaxy followed geometric layouts that looked closer to engineering than natural physics, as if entire regions had been transmuted deliberately. The possibility that matter itself was rearranged on cosmic scales is unsettling enough, but Webb found something even more disturbing. The light from these ancient galaxies carried hidden messages written into its very structure. Light is supposed to be the universe's simplest messenger, carrying raw information about where it came from and what it passed through. But Webb's observations of ancient starlight show signatures that make no sense at all. Photons that left their sources more than 13 billion years ago should only reveal hydrogen, helium, and perhaps traces of lithium, the primitive ingredients of the early cosmos. Instead, Webb detected complex molecular fingerprints, organic compounds, and heavy metals embedded in light that should have been too young to carry such sophistication. Even stranger, the polarization patterns of this ancient light suggest it passed through invisible structures that should not exist in empty space, bending and reshaping the photons in ways beyond any known process. And the light wasn't random. It pulsed. Webb recorded brightness variations, repeating with mathematical precision, some resembling binary code, others echoing prime number sequences. It was as if the first stars were broadcasting, not just burning. Even the stability of those stars was suspicious. Instead of chaotic, violent beacons expected from primordial giants, their light output was remarkably consistent, as though regulated. Ratios of elements in their spectra were too perfect, tuned exactly to produce conditions favorable for Earth-like chemistry, billions of years before our own world formed. The implication is staggering. Either the first stars were operating under laws of physics completely different from those we see today, or intelligence was present in the universe almost from the beginning, embedding messages in light itself. And if stars could pulse with hidden codes, what would happen when entire galaxies collided? When Webb turned its gaze toward colliding galaxies, it captured something even stranger than impossible stars or planets: cosmic crashes happening on fast forward. According to physics, when two galaxies meet, their merger should take hundreds of millions of years, as gravity slowly pulls them together, scattering stars in chaotic arcs. But Webb has seen mergers finishing in just a few million years, far faster than any simulation allows, and the results were not the violent wrecks astronomers expected. Instead of randomness, the stars and gas reorganized themselves into elegant, symmetrical patterns, almost as if choreographed. In some cases, debris streams didn't follow the laws of momentum at all, curving back on themselves, spiraling in impossible loops, or even appearing to flow backward in time, with light from the collision reaching us before the event that created it. Even more unsettling, Webb found that these galactic mergers were not isolated. Across billions of light years, multiple galaxy pairs were colliding in near-perfect synchronization, producing matching structures as though connected by some hidden network. Gravitational waves from these crashes also carried bizarre frequencies, hinting that the galaxies were tapping into dimensions beyond the three we know, reshaping space-time itself as they merged. It was less like watching destruction and more like witnessing construction, as if the universe was deliberately engineering new forms of galaxies. And if entire galaxies could dance with impossible precision, what about the lonely worlds, drifting far beyond the reach of any star? Rogue planets were once thought of as cosmic castaways, worlds flung from their home systems to wander forever in frozen darkness. But Webb has revealed that many of these starless travelers are anything but dead. Some radiate heat like miniature suns, maintaining surface temperatures hot enough to keep oceans of liquid water flowing even in the void. Others show weather systems swirling in thick atmospheres, complete with clouds, storms, and even seasonal shifts, despite having no star to drive them. The mystery deepens when you look at their movements. Instead of drifting randomly, clusters of rogue planets travel in formation, holding precise geometric distances from one another, as if moving in fleets. Webb has even detected radio emissions from some of these worlds, signals with modulation patterns that don't resemble natural sources but echo the hallmarks of communication. Infrared imaging shows surface features too precise to be geological, vast hexagonal grids, sprawling straight-line structures, and patterns etched across continents that look engineered rather than natural. Even their magnetism defies logic. These planets generate magnetic fields stronger than Earth's, without the molten cores needed to create them, suggesting they tap into unknown energy sources. And strangest of all, some of these rogue worlds appear to be steering themselves, adjusting their trajectories as if guided by intention, charting courses towards specific destinations in the galaxy. If planets adrift in the interstellar dark can sustain heat, weather, and possibly even intelligence, then maybe the boundaries of habitability are far wider than we ever believed. And if water is the key to life, Webb has uncovered it in places even more unlikely than these wandering worlds. Water should be one of the most fragile molecules in the cosmos, easily torn apart by heat, radiation, or violent stellar winds. Yet Webb has uncovered vast reservoirs of it in places where it has no right to exist. In the heart of the Orion Nebula, where temperatures soar to thousands of degrees and ultraviolet radiation blasts everything in sight, massive clouds of water vapor float serenely stable across light years of space. The molecules not only survive, they thrive, forming concentrations denser than Earth's tropical rainforests. Even stranger, these cosmic water clouds don't behave like random gas. They organize into filaments and bubbles that resemble the structures of living cells, circulating and flowing in currents that look more like weather systems than chemistry. Some appear to recycle themselves endlessly, creating interstellar water cycles in the vacuum of space, with no planets or atmospheres to drive them. Webb's instruments also picked up organic compounds dissolved in these clouds, molecules normally linked to biology, floating thousands of light years from any world, and the water seems to spread as if replicating, appearing in regions where none existed before. In certain cases, it even violates thermodynamics, existing simultaneously in states that resemble liquid, gas, and solid, stable under conditions that should instantly destroy it. This resilience suggests water might not just be a byproduct of chemistry, it may be a fundamental structure of the universe, one that emerges wherever conditions allow, no matter how hostile. If water can persist and even grow in the most violent regions of space, then life's essential ingredient may be far more universal than we ever imagined. But Webb didn't just reveal the endurance of water, it exposed something even stranger, time itself breaking apart under the weight of the cosmos. Dark matter was supposed to be simple, an invisible scaffolding, interacting only through gravity, shaping galaxies while remaining silent and passive. But Webb has revealed something far more unsettling, dark matter behaving as if it has a mind of its own. Instead of forming smooth halos around galaxies, it weaves into intricate geometric networks that stretch across millions of light years, patterns that look eerily similar to neural pathways in a brain. Even more disturbing, these structures shift and reorganize over cosmic time, as though adapting, responding to the movements of normal matter with precision and speed no gravity-based model can explain. In some regions, dark matter even flows between galaxies in filament-like highways, transporting invisible mass as if part of a coordinated system. Webb's gravitational lensing data shows halos that don't just react to nearby galaxies, they anticipate them, forming concentrations exactly where new galaxies will appear, millions of years later, as if predicting the future. Stranger still, multiple dark matter networks separated by enormous distances shift in unison, synchronized like nodes in a cosmic web of communication. Some distributions even follow mathematical ratios, too precise to be random, hinting at organization or coding. The most unnerving implication is that dark matter may not be inert at all, but a complex dynamic system with emergent properties, perhaps even awareness. If the hidden majority of the universe is not just matter but something closer to intelligence, then everything we see, galaxies, stars, planets, even life may be shaped by an unseen architecture that thinks, learns, and evolves on scales far beyond our comprehension. And if dark matter can act like a network, what Webb saw next suggested that even death in the cosmos doesn't always follow the rules. Supernovas were supposed to be the final curtain for massive stars, a single violent explosion that ends a stellar life forever. But Webb has witnessed stars refusing to stay dead. In one galaxy, a star labeled SN 2023 ABC exploded in brilliant fashion, faded as expected, and then months later erupted again, brighter than before. By the end of the year, it had exploded 5 times, each blast more powerful than the last. It was a cosmic phoenix, resurrecting itself against the very laws of physics. Even more baffling, the explosions weren't chaotic. They followed precise mathematical sequences, some aligning with Fibonacci patterns, others echoing prime numbers, as if the universe itself was counting through fire. Spectra from these repeat blasts revealed nuclear processes that shouldn't be possible, stars detonating while still burning lighter elements like helium, skipping the iron core collapse that defines supernova theory. Even stranger, some of these explosions occurred before the conditions for collapse were met, as if anticipating their own deaths. And in the debris, Webb found remnants that made no sense. Pure isotopes of elements that should vanish instantly, or entirely new combinations that don't match any known nuclear process. Even more chilling, supernovas separated by millions of light years erupted simultaneously with matching energy signatures, as if communicating across the cosmos in bursts of stellar death. Some shockwaves even traveled faster than light, reaching distant regions before their own photons arrived. The idea that stars can not only explode multiple times, but do so in coordinated, mathematically patterned events, turns stellar death into something far stranger than destruction. It begins to look like design. And if the end of a star can break the rules so profoundly, what does that say about the beginning of the universe itself? The Big Bang was meant to be the ultimate starting line, the moment when time, space, and matter all came into existence 13.8 billion years ago. Nothing in the universe should be older than that single flash. Yet Webb has uncovered galaxies that appear to predate the Big Bang itself, fully formed structures with stars, black holes, and chemical compositions that would require 15 billion years or more to develop. These ancient giants sit unmoved by cosmic expansion, holding fixed positions while everything else drifts away, as if they exist outside of space-time entirely. Their light is even stranger. Instead of the steady redshift expected from ancient objects, Webb sees it changing over time, growing bluer as though the photons are aging backwards. Within these galaxies, isotopes appear that could only have formed under different physical laws, their decay rates incompatible with the universe we know. Infrared imaging reveals geometric patterns across entire galactic arms, suggesting deliberate modification rather than natural evolution, while faint transmissions ripple outward in frequency bands that resemble communication more than cosmic noise. Some scientists suggest these galaxies are remnants of a previous universe, artifacts carried across a cycle of cosmic rebirths. Others argue they're evidence of dimensions where time runs differently, allowing civilizations to build before our universe even began. The most unsettling possibility is that these galaxies are not natural at all, but engineered constructs, built by intelligences so advanced they operate beyond the constraints of the cosmos we inhabit. If structures can exist before time itself, then perhaps the Big Bang was never the beginning, only one chapter in an endless cycle of creation, collapse, and renewal. And if the universe can recycle, what Webb found next hinted that even the planets we thought impossible may thrive in places where no world should survive. Planets were never supposed to exist in the shadow of magnetars, the most extreme stellar corpses in the universe. These collapsed neutron stars wield magnetic fields so strong they can tear apart atoms, stretching them into needle-like forms and erasing chemistry itself. Their radiation burns hotter than millions of nuclear reactors, and their gravitational pull should fling away or vaporize anything that dares to orbit nearby. Yet Webb has found planets circling these monsters, thriving where no world should. Their surfaces glow with strange luminescence, as if the magnetar's deadly energy is being harnessed instead of resisted. Atmospheres cling tightly around them despite forces that should strip them bare, with chemical signatures suggesting complex cycles, even traces of oxygen and compounds normally tied to biology. Some of these planets appear to synchronize their orbits with mathematical precision, locked in ratios that look more like choreography than chaos. On their surfaces, Webb's instruments picked up infrared patterns, vast geometric grids etched across continents, aligned perfectly with the magnetic fields of their host star. These markings don't resemble natural geology. They look engineered, like colossal circuits designed to channel energy from the magnetar itself. Even stranger, matter seems to flow between star and planet in shimmering streams, maintaining coherence across impossible distances, as though the two are linked by a system beyond physics. And faint radio signals emanate from these worlds, modulated in ways that suggest not random noise, but communication perhaps adapted to survive in magnetic environments no human technology could endure. If planets can exist, adapt, and maybe even build under the crushing grip of a magnetar, then the limits of habitability are far wider and far stranger than science ever imagined. And yet, as extraordinary as these worlds are, Webb's most haunting discovery came not from stars or planets, but from light itself, finding shortcuts through dimensions we cannot see. Light has always been our most faithful messenger, limited by the cosmic speed limit and the straight lines of space-time. But Webb has caught photons breaking the rules, arriving from Andromeda thousands of years ahead of schedule, as if they had taken hidden shortcuts through dimensions we cannot perceive. These fast photons carry the same spectral fingerprints as their slower counterparts, yet their timing reveals they bypassed vast stretches of space in ways Einstein's relativity cannot explain. Some even arrived before they were emitted, suggesting travel through higher dimensional routes where past and future blur together. Their polarization patterns show interactions with matter types that don't exist in our universe, and some carry quantum entanglement signatures that remain linked to their source stars across millions of light years, as if traveling through overlapping realities. Even stranger, these photons often emerge energized, arriving with more power than when they left, hinting they tapped into reservoirs of energy hidden beyond our dimensional framework. And their behavior isn't random. Webb has detected binary-like sequences embedded in their properties, resembling information streams carried across the cosmos. In some cases, photons from entirely different galaxies arrive in synchronized pulses, as though connected to the same higher dimensional network. It raises the possibility that light is more than just radiation. It may be the medium of a vast communication system operating outside of space and time, a cosmic internet weaving realities together. If the universe allows light to travel through hidden corridors, then it may also allow entire civilizations to connect across epochs and dimensions. And as staggering as that is, Webb's next revelation was even more unsettling. Energy itself appearing out of nothing, defying the most sacred law of physics. In the cold emptiness of galactic halos, far from any stars or black holes, Webb has detected energy sources that should not exist. Vast power beacons blazing in absolute nothingness. These emissions rival the output of entire star systems, yet no visible matter fuels them, no fusion burns, no collapse drives their intensity. They appear to be creating energy from the void itself, in direct violation of the conservation laws that form the foundation of physics. Stranger still, the emissions aren't chaotic. They come in clean, precisely tuned frequencies, more like engineered signals than natural radiation. Some grow stronger over time, doubling in power according to mathematical progressions, as if building toward an unknown purpose. Others pulse in structured modulations, encoding data streams that resemble communication rather than random noise. Even more disturbing when massive cosmic events occur, like black holes feeding or stars detonating. These energy sources respond in perfect unison, adjusting their outputs almost instantly, across distances that should take millions of years for light to cross. It's as if they're aware, connected through a hidden network that transcends space-time. Some even appear to anticipate future events, boosting their energy production before the triggers occur, as if they already know what's coming. Quantum measurements suggest these power wells tap into higher dimensions, pulling energy from realities outside our own. And with every observation, their numbers grow, spreading across the galaxy like seeds of an unseen infrastructure. If these are natural, then physics itself is stranger than anything we've imagined. But if they're artificial, then they may be the clearest sign yet that a civilization, or something beyond civilization, has harnessed the universe at its most fundamental level. And just when energy itself seemed alive, Webb turned its gaze to matter and discovered it behaving as though it was conscious. In the Perseus galaxy cluster, Webb uncovered something that unsettled even the most hardened scientists. Ordinary matter behaving as if it were alive. Vast clouds of gas, spanning millions of light years, weren't drifting randomly through space, but organizing into layered, cellular-like structures, complete with internal circulation systems that resembled the veins and arteries of biological tissue. Streams of material flowed through these networks with uncanny efficiency, carrying energy and information across galactic scales in ways that looked more like a nervous system than astrophysics. When struck by cosmic rays or gravitational waves, these structures didn't just react passively, they responded, reshaping themselves as if learning from the impact. Some even split apart in a process disturbingly similar to cellular division, creating smaller, self-sustaining copies that grew in complexity over time. Webb's data showed patterns of adaptation, as though these immense matter systems were evolving, each new generation becoming more intricate and responsive. Even stranger, they seemed to make choices. When multiple paths existed for energy to flow, the networks consistently optimized routes, suggesting decision-making on a scale beyond comprehension. And they weren't alone. Webb detected signals, pulses of energy traveling between clusters that hinted these matter organisms were communicating across billions of light years, forming a kind of intergalactic ecology. Some behaved cooperatively, while others showed parasitic traits, consuming weaker structures to fuel their growth. Perhaps most unnerving of all, they remembered the architecture of these cosmic organisms carried imprints of past events, supernova explosions, galactic collisions, black hole activity encoded like scars or memories, preserved for billions of years. It suggests that matter itself may hold awareness, a form of consciousness written not in neurons, but in stars, gas, and plasma. And if matter can think on the scale of galaxies, what Webb found in the void between them was even more disturbing. Gravity without matter, behaving as though something invisible was building a cosmic machine. In the vast voids between galaxy superclusters, regions thought to be truly empty. Webb has detected gravity itself acting as if something massive were present, despite no visible matter existing at all. Light bends, space warps, and time dilates in patterns indistinguishable from the pull of billions of suns. Yet surveys confirm no stars, no dark matter halos, no black holes. These anomalies don't behave like random distortions either. They arrange themselves into precise geometric networks spanning hundreds of millions of light years, as though someone or something is sculpting the fabric of space. Even stranger, their strength fluctuates over time in rhythmic sequences, producing lensing effects that focus certain cosmic signals while ignoring others, almost like a filter choosing what we're allowed to see. In some cases, the anomalies anticipate the motion of objects, bending light or guiding cosmic rays toward exact destinations before those objects even arrive, functioning less like gravity and more like navigation. Webb has also picked up gravitational waves from these voids, carrying structured patterns, not the chaotic ripples of colliding stars, but modulated signatures eerily similar to artificial communication, and the effects grow stronger with each observation. New anomalies are appearing where none existed before, while old ones expand, linking into vast networks that seem to span intergalactic space. It raises a terrifying possibility. Gravity may not be just a natural force, but a tool shaped and directed by hidden systems, older and larger than galaxies themselves. If that's true, then the void isn't empty at all. It's infrastructure, a machine built into the fabric of the universe. And just when scientists thought the revelations couldn't get stranger, Webb intercepted signals that didn't just cross space, they came from beyond the limits of the observable universe. Webb's deepest surveys into the cosmic microwave background, the faint afterglow of the Big Bang, should have revealed nothing more than tiny fluctuations in temperature, the seeds of galaxies in a young universe. Instead, it uncovered patterns that shouldn't exist at all, geometric structures repeating across vast stretches of sky, precise and mathematical, as though imprints from realities beyond our own. These weren't static scars from creation either. They shifted over time, evolving in sync with major cosmic events, hinting at ongoing interactions with parallel dimensions. Even more unsettling, hidden within the temperature fluctuations were binary-like sequences, encoded patterns resembling streams of data rather than random noise. Some of these sequences appeared to reference future events, galactic collisions, black hole eruptions before they happened, suggesting they originated from timelines where past, present, and future unfold simultaneously. In certain regions, light itself behaved as if taking shortcuts through higher dimensional corridors, arriving before it should, carrying information from structures outside the observable cosmos. Galaxies near these dimensional hotspots displayed warped shapes and energy signatures that could only be explained by forces leaking in from beyond our universe. The implications are staggering. We may not live in a single isolated cosmos, but inside one layer of a much larger multi-dimensional network, where intelligence, matter, and energy move freely between realities. And the most haunting revelation is that some of the encoded signals look intentional, as if someone or something has been trying to communicate across universes, embedding messages in the very fabric of cosmic radiation. If that's true, then our universe itself may be part of a larger conversation stretching across infinity. But Webb's most unsettling discovery was yet to come. Galaxies so ancient, they shouldn't just predate physics, they shouldn't exist at all. The Big Bang set the supposed boundary of existence at 13.8 billion years, yet Webb has uncovered galaxies that defy that limit. Structures so ancient they seem older than time itself. These impossible galaxies are fully formed, packed with stars, heavy elements, and supermassive black holes that would take tens of billions of years to develop, existing in a universe that by our models had only just begun. Stranger still, they don't drift with cosmic expansion the way every other galaxy does. Instead, they remain fixed in position, as though they exist outside the framework of space-time entirely. Their light carries even deeper mysteries, redshifts that don't just stretch, but reverse, turning bluer over time, as if the photons themselves are moving backward through history. Within these galaxies are isotopes that couldn't have formed under our universe's laws, their decay rates incompatible with known physics, along with elemental compositions suggesting nuclear processes from an entirely different reality. Infrared imaging reveals structures too precise to be natural, spiraling grids, luminous geometric arcs, and continent-sized energy patterns etched into the very stars themselves. Most disturbing, faint signals pulse outward from these galaxies in modulated frequencies, repeating like transmissions, as though civilizations older than the universe itself are still speaking. Some scientists propose they are remnants of a previous cosmic cycle, survivors of a universe that collapsed and rebooted, carrying forward technology and memory into ours. Others whisper about intelligence so advanced it can build galaxies the way we build cities, engineering entire structures outside of time. If these galaxies truly predate the universe, then the Big Bang wasn't the beginning, it was just another threshold in an infinite chain of creations. And if that's true, then perhaps the very stars we see aren't the oldest story Webb is telling, because even worlds orbiting the deadliest stars in existence are rewriting the rules of creation. The James Webb Space Telescope was meant to confirm what we already believed about the cosmos, but instead it has torn open reality itself, revealing a universe that is older, stranger, and far more alive than anyone expected. From galaxies that shouldn't exist, to stars reborn in defiance of death, from planets thriving under the crushing grip of magnetars, to rogue worlds wandering in coordinated formation, the discoveries point toward a cosmos guided by principles we don't yet understand. Perhaps even intelligence woven into the very fabric of matter and time. Water survives in stellar furnaces, black holes communicate across light years, and light itself takes hidden shortcuts through dimensions beyond our reach. Energy emerges from nothing, matter organizes like living tissue, gravity bends in empty voids as if part of some vast machine, and signals embedded in the microwave background suggest voices calling from parallel universes or from before the Big Bang itself. Webb has shown us that the laws we thought unbreakable are not laws at all, but temporary rules in a reality far more complex than we can grasp. The deeper we look, the more it seems that consciousness, order, and design are not rare accidents but fundamental forces shaping the cosmos. Humanity stands at the threshold of understanding, staring into a universe that may not just be observed but may be watching back. The question is no longer whether the cosmos is stranger than we imagined, it's whether we are ready to face the truth that it is stranger than we can imagine, and our role in it may be far more important than we ever believed.